Welcome. Today we're going to look at solving logarithmic equations, and this is video number 3. So let's go ahead and get our notes out and we'll get going. If you fall behind in your notes, remember to pause the video to get your notes caught back up. And if you didn't quite get something the first time, stop the video, rewind it, and listen to it again. Sometimes it takes a couple times through to understand the concept. Okay, let's talk about or do a recall on the definition of a logarithmic function. Now this is right out of regentsprep.com, and it says the logarithmic function is the function y is equal to log base b of x, so nothing new, where b, which is my base, is any number such that b is greater than 0 and not equal to 1. So again, that simply means our base has to be a positive number, which number is greater than 0, but it can't equal 1. The piece we want to focus on is our argument x, which is our domain. It says our x's must be greater than 0. Our x's must be positive. And that's going to come into play as we solve. We may end up solving and getting solutions that are outside our domain. Solutions that make our argument negative. So we're going to have to look for those and check our work. Alright, here's our first problem. So let's go ahead and write it down. We have to solve, so write this down, log of 2x plus log of x minus 5 is equal to 2. As we've gone through our series of videos, our first step keeps changing a little bit. So we're going to kind of tie it all together right now. Our first step is to isolate our logarithmic function, which might be condensing. I see here in our equation to isolate a log, well, I've got 2 logs. So what I have to do is use my properties of logarithms to condense it down to 1 log. So again, our first step is to isolate the log or condense it to 1 log. So let's go ahead and use our properties. Now our product property says if I have logs with the same base being added together, I can rewrite it as 1 log. So here I go. This is our product property, where we multiply the argument. So this would become 2x times x minus 5, and that's equal to 2. Close my bracket, and this is our product property. Alright, so we condensed our logs using our product property down to 1 log. Okay, our next step is to identify the base. Now, with a log, excuse me, the base is understood to be 10. This is our common log, so I'm going to scribble in a 10 quickly. Okay, so this is base 10. So again, we are going to exponentiate both sides by 10. Alright, so this becomes 10, and our logarithmic expression now becomes our exponent. So this is 10 to the power of log 2x times x minus 5 is equal to, and so does this side, this is 10 to the second power. So again, we're exponentiating both sides by 10. Okay, we do this because we want these to cancel out. 10 to the log base 10 power cancels out, and we're left with 2x times x minus 5, and that's equal to not 2 but 10 squared. By exponentiating both sides, our logs cancel out, and we're left with an expression we know how to solve. I'm going to do some simplification. Distributive property says this is 2x squared minus 10x is equal to 100. Now, unlike our previous examples, this is not a linear equation, this is a quadratic equation. So now we have to look at solving our quadratic, which means factoring or quadratic formula or completing the square. I'm going to attempt factoring first, so I'm going to set everything equal to 0. Minus 100, minus 100. I'm going to go up here. I get 2x squared minus 10x minus 100 is equal to 0. So I'm attempting factoring and the zero product property. First thing I notice, they have a common factor by 2. So I'm going to factor out the 2. That's x squared minus 5x minus 50, which equals 0. Now inside, I'm going to look for factors of negative 50 to add up to negative 5. And hopefully they exist. Otherwise, we're going to have to jump to the quadratic formula. So right away, I know this will be x, this will be x, so this is just factoring. So factors of negative 50 to add up to negative 5, that appears to be, hopefully, 10 and 5. And because he's negative, that means my 10 must be negative and my 5 must be positive. So some quick factoring. I came up with 2 times x minus 10 times x plus 5, so that implies my solutions are 10 and negative 5. So this one, there are 2 possible solutions. Okay. Now the last thing we do is you have to check our answer, and what we don't want is an argument that's negative. So right away, just by plugging or by substituting into the original equation, sorry, I got a little tongue-tied there. This is log base 10 of 2 times. I'm going to go ahead and plug in the 10 first. And I can see right away that this 10 will leave me with an argument that stays positive. 2 times 10 is 20, so this is log base 10 of 20 plus log base 10 of 5. Now I don't know offhand what these are. I don't know if they're going to equal 2, but I do know that they are possible answers because my argument is positive. So 10 is a possible solution. Alright, let's check the next one, negative 5. So I have log base 10 of 2 times with a simple substitution plus, I don't have to go any further because right here I see this is log base 10 of negative 10. I can't have a negative number. Therefore, negative 5 is what we call our extraneous solution. It appears to be a solution. We solved everything correctly, but when I plug it in, it leaves me a value outside my domain. So my solution to this problem is x is equal to 10. So again, to go over the steps, the first thing we do when we solve logarithmic equations is isolate the log and or condense down to at most 1 log. So here it was a condensing problem. I had 2 logs. I condensed it down to 1 log using properties, and that was the product property. And then just like the same step we did in each and every other video, we identify the base and exponentiate both sides by that base because we want them to match. And we want them to match so they cancel out. And then I was left with something we know how to solve. This particular example was a quadratic. We solved it by factoring. Quadratic formula and completing the square would also work. And then once we got our solutions, we had to check them. And we noticed that our solution negative 5, when I substituted back into the original equation, left me a negative argument, a value outside the domain. So our only solution to this problem was x is equal to 10. Alright, if you have any more questions, make sure you jot them on the side and we'll answer them during class.